have a code in Revit. So with information for major things that we need to consider.
Hello, everyone. Welcome to Plugin Playbook webinar. We are going to wait for 1 minute for people to join in, and then we'll start with the webinar. Oh, I think we can start now. Hello, everyone. My name is Hardik Makrubia, and I'm computational designer here at CoTool. And I have David Spillane with me, who's gonna host this webinar with me. So in this webinar, we are going to go through all the plugins that are supported by CoTool to export your geometry. Go to next slide. So in this, the agenda for this webinar is going to be, we'll have a basic introduction of what we require for simulations and what geometries you will be requiring to export so that you can calculate for energy analysis. Then we will have an overview of our plugin resources, and we'll go through each plugin that how that can be used to export your geometry and what are the best practices for those export. And at last, we'll go through the mixed use export when you have a mixed use project. And at the end, we will have Q&A, but you can still posting your questions in our Q&A session, Q&A block. So So, uh, for building simulations from BIM to BEM, which is the building energy modeling, the the four key ingredients that will require for simulations is gonna be uh, recreating the condition of weather file. So that is all coming from your project location, and based on your project location, we'll be getting your weather file data, and then we'll require your model representations of your building, of your geometry. And the third is we'll require the performance aspect of all those geometries, as well as understanding your condition space, which has been like coming from the energy code, which is again tied to your project location. So with this information, we'll be able to simulate energy calculations for you. Next. So, so to understand like what geometry we'll be needing for your energy analysis is like any part of your building that's gonna be like having any impact in heat transfer. So all those part will be part of your like geometry that we needed in through plugin uh, to calculate your energy analysis. Next. So Andrew describes the thermal envelope as like everything about a building that serves to shield the living space and the outdoor space. So whenever you export your building for energy calculation, the only information that you need to send is whatever surfaces or the geometry that is part of your thermal boundary, which is gonna be a shield between conditioned space and the outdoor space. So you are only supposed to send those information in for energy calculations. And so in this plugin, which David's gonna go through like each of them, in that you will be able to see like different layers. In terms of Revit, you will have different views. So that's how we are segregating this information, and that's how the plugin is providing those information to the core tool to understand what part of your building is wall, what part of your building is window, and all.
So, based off the plugin poll, seems like Revit is leading the way, but we will touch on all of the four main ones: Revit, SketchUp, Rhino, and ArchiCAD. Just a quick overview of the plugin resources. We have an app store where you can go and download all of the plugins that we provide. The Cove tool platform links to all current workflows to ensure that you can seamlessly update your models in every stage of design. We are constantly working on these plugins to keep them up to date and meet current industry demands. The help articles and tutorials we provide along with these plugins are there to make you guys successful at uploading and analyzing your geometry. The first plugin resource we'll review is Revit. One important thing to note here is if you go after installing your plugin, if it comes up with an error, some of the steps involve unblocking a zip folder before you install, or you may have a firewall issue. So unblocking it through the firewall may help get it installed, but otherwise it should be pretty straightforward. For ArchiCAD, there's a couple of options to installing. One of them is by placing it in the ArchiCAD add-on folder, or going straight through ArchiCAD after you've opened up your project and going through the add-on manager and adding it there. You will be able to find the window, the Cove tool window, at the bottom of the palettes list. We actually are getting ready to release a plugin for ArchiCAD 27, so be on the lookout for that. For SketchUp, once again, pretty straightforward. It's important to understand that if you have a current SketchUp plugin and you're trying to install a new one, that you install that plugin first. The plugin integrates SketchUp directly into your workflow, so this plugin helps upload your geometry to help automate the building performance analysis. And for the Rhino Graphic plugin, before you begin here, you want to make sure that you've got the plugin folder downloaded, a Cove tool project created in the app, and a Rhino model ready for export. Next, you want to make sure that the Cove tool project created to have the Cove tool project created on the app, and before you begin the exporting process. A pre-created project is necessary for the new plugin. It requires the project's URL to export the geometry. Next, we'll be going over setting up your model in the plugins we just went over. Typically, regardless of the BIM platform, kind of all of the plugins follow the same 4-step workflow, meaning you update your login, you select your project, you create your Cove tool views, and you export. Depending on the platform, there may be some additional steps that are placed in between some of those other steps to before exporting. Here on Revit, our Revit plugin 4.0, you'll notice that we've revamped our user interface. It now kind of includes a sleek ribbon menu. It makes it easier than ever to access the plugin's powerful features with intuitive icons and organized menus. The updated plugin now enables you to visualize room geometry as 3D masses directly in your 3D model as well. This feature simplifies the process of identifying and rectifying room geometry errors before importing your room data. For the kind of the process for getting the correct geometry in the correct manner into the plugin, the plugins use a geometry front face and back face properties to determine orientation, and then they're categorized. So being able to check your views before exporting is important, because sometimes it will put elements in views that you weren't intending them to be there, and sometimes it will hide it in other views, and so you need to make sure that you have the correct geometry and the correct views. With the Revit 4 plugin, you can now there's a hide elements in view button that allows you to click the button when the element is selected and hide it. One of the important parts after you've gotten all of these elements into the correct categories and you're exporting, you've exported, you'll get a export report that has a comprehensive triangle count. And this way you can review, if you're over the triangle count, you can review which elements that you went over with, and work to simplify the project to allow it to import or export to the Revit plugin. There's also a timestamp where you can review the details of the last export you made for the model, and that helps with understanding what may have gone wrong. The ArchiCAD workflow, as I said before, it introduces another step to the 4-step process, and that is classifying the model. When you press the Cove tool views button, it automatically categorizes the building elements into different Cove tool categories based on the position attribute of the element. The categories are roofs, floors, and exterior walls, etc., much like the other plugins. This can take a few seconds depending on the complexity of the project. For some elements may not be classified if the plugin did not identify any geometry with the correct position ID and properties. So you want to make sure that you've checked all of the elements and that they're in the right category. The way that ArchiCAD classifies its elements, Cove tool has created a classification system, and when you create your Cove tool view, it creates a graphic override on the existing 3D view based on the element classification. Like I said before, you want to visually inspect the objects and classify any missing objects to their proper assignment. You want to make sure to simplify the geometry selection and only classify building elements that will impact the thermal envelope when trying to do your analysis. For the SketchUp workflow, we've now added two steps to that 4-step workflow, and the ideal workflow is understanding that you need to create a new file or duplicate your file, so that you don't, when going through the exploding process, that you don't, you want to only use one surface, so that may not be conducive to what you're using SketchUp for at that moment. So you want to create a separate SketchUp file just for 3D analysis. It's best to, the file should only contain the main building's geometry, rendering elements, structural elements, site elements, they're not typically needed for analysis. So it's best to hide those or get rid of them altogether, so that your results, you can get results more quickly, and you reduce the amount of inaccuracies. If you have building context you'd like to see imported for daylight analysis, then that may also be included. One of the new buttons that's here for use is the flipping a reverse face. One important part of SketchUp is that it has a front and a back face. So you want to use the flip face button tool so that you can see a view where it's highly contrasting colors, and you're able to figure out which surface should be facing exterior, which surface should be facing up. It's crucial that exterior walls and windows displaying front-facing surface outwards, and roof geometry have their front planes facing upwards, while floors have their front planes facing downwards. Once the model is ready, and you've clicked the Create Cove Tool Layers button, new layers will appear at the bottom of the tags menu. Make sure all the objects have been sent to their correct category by going through each one. Any misplaced objects can normally be swapped between layers. So make sure that before this is done exporting your geometry, that it is everything is in the correct view. Misplaced objects are the #1 cause for inaccuracy with the SketchUp plugin. Onto Rhino and Grasshopper. The workflow is pretty straightforward. We've kind of thought through the process with some scripts, and the first step would be to log into your project and connect it to the Cove tool by providing an ID. In the second portion, you will check the project and see all the building type uses. You will then assign elements to specific categories per building type, and if you have 2 building types, you'll need to do that for each. And then you're able to press upload type. You're able to upload each type individually. You then need to refresh your geometry page to see that the values have been updated. Some of the best practices for model export we've kind of written down and thought about. One of the best practices with Revit is that we see a lot is Revit families, is to make sure that all elements inside the family are set to the correct subcategory. A common example is generic models being used for windows. Having all the elements within that family set to the correct subcategories like glass, frame, and mullion allow for a smoother export. Some of best practice in SketchUp that I see a lot is when you run the plugin and then you come back and make some adjustments, you need to make sure that all of your edge line tags are set to untagged. Best practice right before you export again would be to select all the elements in the project, right click, hover over select, and click to deselect all the faces. And that way you have all of your edges selected, and then you can set them all to untag before exporting. One good practice in Rhino is to make sure your final stage model is only single surface objects that are not locked, grouped, blocked, or in any other way connected to a solid or combined with any other geometry. Units must be in feet. Only geometry on Cove tool layers will be referenced. Delete all bad objects and purged unused file elements. Ensure all surfaces are facing the correct direction with the front face facing outward or upward. All geometry should be the X and Y plane, and only geometry above ground should be exported. To quickly go over the mixed use workflow, we'll use Revit as an example here, but when creating a mixed use project, the key is knowing where the building splits into a new function that demands different inputs. There are different mechanical strategies for different spaces in the building. Since these these spaces will both contribute to the EUI, but have different expenditures dependent on the use. It is important to split these spaces to demonstrate their operations schedule. Here you see, like I said, the example in Revit above shows the process of assigning geometry. What's important to remember here is to make sure that you have the correct elements and the right building use type views, and that you have the right use type selected on the geometry page in Cove tool when exporting. As you see in step 4 above, you can export each view individually after deleting the suffix, or in addition to, you can remove all the suffix for all the views of the same use type and export all. After exporting, you can hit undo, get those suffixes back, and then for the exported use type, and then repeat the process for the other types. And I think that is it. If anyone has any questions, please feel free to ask.
So
I
we
see
have
one. Yeah, go ahead, Arctic.
Yeah, you can go ahead.
Yeah, I see one question here. How can I ensure that my geometry has imported accurately and is optimized for energy analysis? That's a good question. We have a lot of people here who are industry professionals who can help ensure that it is accurate and that it has been optimized. We provide a way of assisting you in your project if you need help, and running it through our tool if you need that.
And addition to that, if you want to check those things by yourself, so when you export this information to 3D analysis, so on the 3D analysis page, we have element selection where you can check for each surfaces if that is accurately imported.
I got another question. What would be the best way to troubleshoot import issues? I've tried to import in the drawing view and found out about 30% of the floors and walls and windows missing. I'm assuming it's the drawing tool view that is this person. Yeah, this person is talking about. The easy way to check to see if there's an issue with something is to export per view. But in some instances, drawing tool, the way that it creates its rooms is by using rooms and then closing it the space in around it. So sometimes it will over analyze a space and add an extra wall or remove an extra wall. And in that case, you will have to go into drawing tool and correct it there. Hardik may have some more to add to that.
Yeah, because drawing tool is tend to close all the spaces so that it can create zone. That's how you can make your geometry watertight for a detailed energy analysis. So that's the reason why you might like have overlapping surfaces, or some of them will be missing because of that. So you will need to like do a little bit cleanup in a drawing tool to accurately demonstrate the accurate representation of your model.
I'm not seeing any other questions. If you end up having any questions, feel free to reach out to us via live chat or email. We are always happy to answer.
If we don't have any more questions, we'll end up the webinar over here. Thank you so much for attending, and we're happy to give you a 5 minutes back. Thank you.
Thank you, everyone.